Hello again. It's good to see you again. I'm going to talk to you about chapter 6 now. So this is the gas law chapter, and there's some math in this. It's not as bad as chapter 5, but there's quite a bit of math in it, and so let's get going. Chapter 6 is all about gases and the gas laws. So here's an opening essay about the Hindenburg, which is a huge explosion, and then it's going to talk to you about what we think, what the theory we use to think about gases. So read through that, and it's all concepts, so not too bad. Then the first math in this chapter is part 2, which is the pressure. So they're going to show you how to use units of pressure, how to convert between them. It's important, so learn how to do that. It's not too hard though, so you guys should be good. And pressure is force over an area, so look through that. I have a little bit of homework on that, homework questions for you guys. But then this is where the important part is the gas laws. We're going to use, I'm going to focus mainly on the combined gas law and the ideal gas law. So these laws here are Boyle's and Charles. We can use both of these within the combined gas law. So read through this and understand what they're talking about, but we're really going to use 2 gas laws in this chapter that I think we're going to focus on the most, is the ideal gas law and the combined gas law. So the combined gas law has these relationships in them. So I think it's just easier to talk about a combined gas law instead of these individual laws. But understand the concept of this for these laws so you get the idea of what's happening. And lots of times you can just relate this to a balloon and what's happening to the gases in a balloon. So read through that. And there's lots of practice problems. But we're going to use this one called the combined gas law to help us in all of them. And combined gas law talks about pressure, volume, and temperature. And we're always going to use Kelvin temperatures. We learned about that a long time ago. I think it's in chapter 2. So go back if you've forgotten how to do that to remember how to get to Kelvin. We have to use Kelvin temperatures to make the math work out. And I think they explain it in here again how to use Kelvin law. So we're going to use combined gas law for a lot of the work we do in this chapter. So get used to that one. And then the other thing we need to learn is the ideal gas law. So this one here is talking about going to talk about moles, pressure, volume, temperature, and we have to use degrees K in this as well. We have to use Kelvin, and we're going to look for numbers of moles in this one. So that's called N. So you're going to use N. When you see a gas law problem that has grams or moles in it, then you know you have to use the ideal gas law. If you don't see moles or grams in the problem, then you're going to use the combined gas law. So that's a hint to remember which gas law to use. And the other part about the ideal gas law, here's the ideal gas law here. So we have N for number of moles, and then we have this thing called R, and it's just a constant. So don't make this a big deal. R is just a number. So we're going to use these numbers for R depending on the pressure that we have. So you have to make sure you know what pressure units we're in, so you can figure out which R to use here. So they're going to show you how to do that. And then the other thing, another important thing to know is what STP is. So write this down, memorize it. What STP is. We're going to use 1 atm and 273 degrees K for STP. So just memorize that. We're going to use that a lot. So whenever you see STP in a problem, it means that we have 273 degrees K and we have 1 atm as our pressure unit. So write that, memorize that, commit that to memory. We need that a lot. And then explains how we use gas laws in our breath. And another good thing to know is that STP, 1 mole of a gas, any gas, it doesn't matter what kind of gas, is going to occupy this volume, 22.4 liters. So sometimes that's a shortcut way of getting answers if you know that relationship right there. So that's an important relationship. And then they're going to talk about gas mixture. So if you add gases together, the total pressure is the addition of all the pressures of the individual gases. So it's a simple equation. It's very easy. Don't make this harder. This is a very easy one. Don't make this harder than it is. It's just the total is going to be the addition of all the individual pressures of gases that you have. That's an easy equation. And then I think that's it. Yes, so this is where you're going to find the homework. So remember, the homework's here and the answers are after this. So do your work and check your answers. Make sure you show me all of your work so I can give you full credit. And have a great day. Good luck with the gas law chapter.